as I was saying there, right? We need to remember that, right, so you have a container with gas particles and they're moving randomly. You want to increase the pressure in here, right? To increase the pressure, you have to make the particles collide more. So how we could do that? Number one, heat it up. More energy, it will expand, right? Pressure will increase and this container might expand. Next thing is to drop the volume. If I make it smaller, pressure in here will be larger. You'll ever try to push the cork off and they keep turning and turning and turning. What are you doing there? You're making the volume smaller and you're increasing the pressure inside. Okay? And next thing is to put more air in it. Okay? They will collide more, pressure will go up. Okay? So that's what we did last day. Now we want to take a look at the questions in applying these things and then we're doing the gas laws. Anybody read up on the gas laws? Take the handout and take a little read. Like a page. Maria says she can read it. Nice. All right, nice. So we have a few questions here to do before we do gas laws, right? We already investigated the gas laws last day, right? In the simulation, right? But we'll go it over again. Right, here we have 4 questions to do and 1 to research. Or we could look at Brownian motion, actually. Take a little read and write a small explanation based on kinetic theory. Once they say based on kinetic theory, you have to talk about the particles, how they move and how they behave and so on, right? That's okay? Go ahead, answer each one. right? When you all finish online, let me know, right? So we'll start to look at it. Yeah, Nathan, wait, say no. Nathan, you answer no, right? Go on. Finish. Anybody working online still? Well done. Right. Let me see. Tishon done. Last one. Right. Chloe, nice. Kilebi done. Annalie. Okay. Last one. Ignore 5, right? Don't do 5. Just 1 to 4. All right, let's go. Let's start answering them, right? So use kinetic theory to explain why a ball appears inflated when placed in the sun. There we are. Just like that part about ball. Come ahead. All right, you're just missing out a few little things. Yeah. Right? So here's the word I'm looking. Here's how many words I'm looking for. The sun will increase the temperature, right? Which would give the particles more energy. Particles will move faster, collide more, and increase the pressure. Okay? So write that down. Right? So those are the key things you're looking for. Yeah? Right? And then you talk about the move faster, collide more, and increase pressure. Right? So you have to have that little sequence, right? So use kinetic theory to explain why a ball of players inflated. So when placed in the sun, it increases the temperature inside the ball. It increases the temperature inside the ball. Which will increase the kinetic energy of the air particles. Which will increase the kinetic energy of the air particles. Full stop. This allows the particles to move faster. This allows the particles to move faster. This allows the particles to move faster and collide more frequently with themselves and the walls of the container. With themselves and the walls of the container. And hence increasing the pressure inside the ball, and hence increasing the pressure inside the ball to make it appear inflated. Right? Remember, that's what we're trying to explain, right? Why does the ball appear inflated? The ball appears inflated because the pressure increases. Why the pressure increase? Particles get more energy and they collide more. Why they get more energy? Because the sun increases temperature. Okay, so let's take a look at number 2. Why does placing more air into the tire increases pressure? Nathan. Right? Right? Very good. Right? Right? So the answer, real simple. More air implies an increased number of air particles inside the tire. An increased number of air particles inside the tire, which will increase the number of collisions and hence pressure. Which will increase the number of collisions and hence pressure. Once you explain in pressure, you cannot escape from being able to state what happens to the number of collisions, right? You have to state that the collisions increase or decreases. All right, so that's number 2. Number 3, let's try somebody online. Chloe, turn on the mic now if you could, and explain how can the pressure inside a hot can of soda be reduced? I just want to type out the whole thing, which I hope you don't want to. Yeah, you want to type out the whole thing? Just turn on the mic now and tell me. I could just say to cool it down. All right, Chloe. Cleo. Okay, Cleo. Right, yeah. But how are you doing that? How are you going to reduce the temperature? Put it in the fridge. Put it in the fridge and let it cool down. What else you could do? Huh? Open it slowly. right? By opening it slowly, you let some of the air particles go out, right? And you just do that. Like if you shake up your Pepsi can and you have to drink it, you're not gonna put it back in the fridge. You open it slightly, let some of the gas particles come out and reduce the pressure in there. Okay? Nice. So that's 1, 2, 3. Anybody have something different? I see what Theo had. The pressure inside the hot can be reduced if placed in a fridge or freezer and lower the temperature. Right? You lower the temperature, they have less energy, less collisions, less pressure. Okay? Number 4, use kinetic theory to explain how a hole in a bicycle tire reduces pressure. Savira? Right. All right, so you stay that okay. So you see how you're using volume and that relationship. That's not a kinetic theory explanation. That's more like a macro, right? When you say kinetic theory, talk about the particles, right? So don't use the pressure and volume inversely related as yet. Okay. So if they say macro, well, you might see that in CSEC. But in CAPE, you have macro and micro. Micro is like particles, macro is like theory. Right? So yes. So since you have a hole, particles will leave. Less particles means less collisions, which means that you will drop the pressure. That's okay? Naria, are you okay there? Online, are you okay? All right. So I want to show you what is Brownian motion, right? The best way to show you is a little simulation. If you all ever had pollen grains and you put pollen grains in water, you could observe what will happen to it. You all may have done that in Form 1 or 2. And sure. Okay. Brownian motion simulation, right? Let me see who was the best. The physics thing was the best here. I think that is it. No, that's not the one I could open. All right, so what you said, that's supposed to be water, right? And you're looking through a microscope, right? That's a water molecule. And what you will notice is the blue part. See this part here? What you're going to observe is that random motion of that blue particle. Okay? That random motion is a Brownian motion. Those small little particles, they're supposed to be like the water particles. Right? And because it's knocking the water molecule around, right, it has that random part. See how random that part is? What's part? Can you figure out where it's going next? Let's see for the wind play with today. You're going up or down? Make a guess. Huh? Left or right? No, look it going up, you're wrong. See? So it's a random part. Okay? Can't really predict where it's going. You're going to the left now it's going up. Now I don't know what happened. You're going in a circle, or it's going back to the right. So now they're going back to the right. So that's the random nature of particles. So Brownian motion, the experiment done by a guy named Brown, Robert Brown, I think, right? He observed the random nature particles. One experiment, he used pollen grains, and he saw pollen grains moving like that. Next example, he had looked at smoke particles. All right? That was nice. Oh, that you put some more particles now. Ah. Right? Anyway, so that is your Brownian motion, right? So to just give you a little idea of what Robert Brown did. Okay, nice. Let's take a look now at, let's go back now to our simulation on gas laws. Right. So we said that let's take a look at the gas laws, right? So we have 3 gas laws. Hopefully you all read them. Right? You read it. Right? So here's what we're going to look at. We are going to take a look at how pressure and volume and temperature are related. All right? But we're going to hold something constant. So in the first case, we're going to see how pressure and volume related by keeping temperature constant. Right? We did it last day, but let's actually keep one constant here. So let's keep temperature constant. How are we doing that here, boy? I don't have the option. All right, so I'm going to keep temperature constant, right? So look at the particles in there. Look how they're behaving. They're moving, they're colliding, they're giving you pressure. So I'm keeping temperature at 300, and I'm going to change the volume. If I make the volume larger, what happened to the pressure value? It decreased, right? I'm going to make the pressure smaller. Sorry, the volume smaller. Pressure increase. So it means that pressure and volume are, what's the word? Huh? Inversely related. Okay? So because they're inversely related, when pressure going up, volume going down. When volume going up, pressure going down. Okay? So from that, we come with a little formula. Right? Here's the little formula. P is equal to K over V. Every time you take off this proportional sign, that proportional sign is the same as an equal sign on K. So move the V across, and you will get PV being constant. So the first formula that we're going to look at is P1, V1, P2, P2. That there is called Boyle's law. Right? Did you note in your handout, but I wanted to write this, please. That's the first law we're looking at, Boyle's law. Boyle's law. Can we get the volume? Is there a way to get the volume value? Or just saying the volume value? Nope. Ain't nobody better than upside down way up. Right? So that formula is seen there, Boyle's law. P1 V1 equal to P2 V2. Are you okay online? Annalie? Tishon? Do we cancel? Tishon. Tishon. You on your phone? Tishon? I seen you online here on WhatsApp. You know? You sure? All right, so that's Boyle's law. Of course, you have to use the right SI units, right? I'll change it just now. Let's take a look at Charles' law. Now leave Charles for last. That's the pressure law. Pew, pew, pew. All right, so that's the first law. But right, this boy always on the phone, boy. Next one. Anybody writing online? Chloe, you writing online? Taking it off, right? Nobody writing, right? Right, so let's take a look now at keeping volume constant. So we're looking at pressure and temperature, and we want to see if we keep the volume constant, what will happen? Right, this law belongs to Mr. Pressure law. Let's see how pressure and temperature are related. Anybody remember? So what's the word? Directly, not directly. Nice. So let's keep volume constant. Let's drop in, let's change to red now. Red particles. Ooh, them red particles, small boy. So it has some blue trapped in there, right? Right, so look at the pressure. I am going to increase temperature. Look at what happened to the pressure. Pressure going up, right? I'm going to drop temperature and the pressure going down. So at constant volume, what does that mean? Right, at constant volume, it means that pressure and temperature are directly related. So the formula looks like this. P is equal to KT, or P on T is equal to K. So your pressure law formula is P1, T1, P2, T2. Okay, copy it down, and I want you to remember that temperature must be in Kelvin. We do not use degrees Celsius in any of the calculations, right? Hey, we could actually do a calculation for this one. All right, and last law. Let us keep pressure constant and change the volume. Right, so we're looking at volume and temperature by keeping pressure constant. This law is Charles' law. All right, so let us now let's put in some red. Let's keep pressure the same. Right, and I'm gonna just change the volume. Can I? Hey, what was that? What is happening there? All right, first let's do that. All right, let me change that. I can't do that. Let's put in some red. Let's keep pressure, but change temperature then. I can't change temperature. Okay, I'm not sure what happened there, right? But it will show you how the volume will change, right? So watch this here. So I'm heating it. So by increasing temperature, the only way pressure staying the same is by increasing the volume. You're saying that? The volume have to increase. By cooling it, the only way to keep pressure the same, have to make the volume smaller. That making sense? Sure. Go ahead. Go ahead upside down. Explain that to me. Why that happening? Charles' law is one of the trickier ones to explain, right? But why that happening? I want to keep the pressure the same. So when I heat it up, the volume have to get bigger. Why? Why? Upside down, say, sure. Yeah. You know why? Okay, so tell me what you know. Why you say you know why? Just tell me why you know. Right? Obviously, the pressure will increase, right? Right? So what would that do? If you increase the volume, what would that do to the pressure? So anyway, the pressure to go back to the original value, right? So that's it. So when you heat it, it will get more pressure, right? But you don't want the pressure to increase. So if you heat it, you're going to have to simultaneously increase the volume, right? Because more volume means less space, so they could run wild and collide less. Okay? That's okay? And if you cool it down, well, we want the pressure to stay the same, so you have to drop the volume. So what does that say about volume and temperature? They are what? Directly related. So the formula is V is equal to KT, V1 T1 is equal to V2 T2. Okay, that's the Charles law. Okay, so those are your three laws that you have to learn. All right, so nice. That is those are your gas laws, right? So we looked at all the gas laws. P1 V1 equal to P2 V2. P1 T1 is equal to P2 T2. All that's saying is that the ratio of pressure and temperature is the same, right? No matter what, right? V1 T1 is V2 T2, right? And we know whose law it is. But you will recognize for the first law, temperature constant. For the second law, volume constant. And the last law, pressure constant. But what will happen if nothing comes? Nathan, what do you think? I see you Googling it just now. Huh? Recorded now. No. Yeah, boy, everything recorded. Yeah. Yeah, Nathan. Nothing constant. What are we going to do? Must have a way for us to combine this, right? So if nothing constant, if pressure, volume, or temperature are not constant, then we use something called the general gas law. General gas law. The general gas law is a combination of all three relationships. P1 V1 on T1 is equal to P2 V2 on T2. Right? That is if nothing constant. Right? The reason I like to learn this one is take a look at the law and blank out T1 and T2. Which law you will get? Take your finger and block out T1 and T2. Which law you will get? Boy's law, right? So if you could figure out what constant, you could take your finger and block it out and figure out the formula for the appropriate law. So for example, Charles' law, pressure constant. Take your finger and block out pressure. And you will get V1 on T1 is T2 on V2 on T2. That's okay? But now give him a marker, boy. All right, you. All right. So general gas law is when nothing constant. These questions, not that difficult, but people tend to get them wrong because they use temperature in degrees and not Kelvin. Okay? So make a note of that in some coloring that you're sure to see, like red, and then write it over again, highlight it, and draw a box around it, and then put a star around the box. Right? Don't forget that. Pimpy. Well, the house will start already on next week. Housework is next week. Next week. So I don't have feeling doing any housework as yet. All right. So let's do some questions, right? Let's go back to the little handout there and do some questions. Right, so we wrote out all the laws already. We have some questions here to do, and then we can try past paper. Right? So we reach the past paper as part of it. Right, one line, send your values, right? Send your values. Oh, sorry, Chloe. So T2 will be 245 by 10 divided by, which is 5, right? So I carry across the 5. How much is that? Sorry, it should be 2. Right? So that's what, 490 Kelvin? Yeah? 490. Nice. So remember, two fractions separated by equal sign, cross multiply. Deshaun, you got that? Everybody okay with that? Let's check the next one, B. Constant volume. So this constant volume, we're using pressure law, right? P1, T1 is equal to P2, T2, and they want us to find T2. So sometimes I like to make T2 the subject one time. Cross multiply, you'll get P2 multiplied by T1 divided by P1, right? That will just help me. I don't want to rearrange anything again, right? P2 is what? 150. T1 is 245. And P1 is 125. How much y'all got there? 98? What? Not looking wrong. How much? 294 Kelvin. $294 Kelvin. Nice. Next one, constant pressure. Right, nice. Aidan, all again, shoot. Aidan. All right, let's go again. Taking this off, right? C, constant temperature. So we're using Boyle's law. I want to make P2 the subject, so I'm carrying across V2. And I will get P2 is equal to P1 V1 over V2. Okay? P1 V1 is what? 25 by P1 is 25 as well, all over V2, which is 60. Somebody got 10.42? Yeah? Pascals. And D, what's the law we're using in D? General gas law, nothing constant, right? So we're using P1 T1, P1 V1 over T1 is P2 V2 all over T2. What they want us to find for? They want us to make T2 the subject, right? So if you want, they could cross multiply, and you'll get P1 V1 T2 is P2 V2 T1. And you want to make T2 the subject, so you carry across now P1 V1. Right? That's substitute and you're good to go. P2 is 550. V2 is 10. T1 is 245. P1 is 225. And the V1 is 25. And when you work it out, how much you got? 200 and how much? Let me just work it out just to make sure. Right, 239.6 Kelvin. Nice. So again, I wanted to see how important it is to be able to make the subject of the formula, right? Two fractions, cross multiply and solve for what you need. All right, let's do a Kahoot. Or you want a past paper? Past paper. All right. Let's do a Kahoot on gas laws. Oh wait, it wouldn't work here. Let's see if it will work here. Everybody love somebody. You are about to add Kahoot. Yes, of course. I know that. I know that. I know it. I know it. Yeah, you want me here, boy? What's going on here, boy? Yeah, boy. All of that, boy. Bam, 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 bam. Add APs and GPs, boy. We're getting APs and GPs tomorrow. Advanced. Friday. Friday. In Akachala, we just form one exam theory. First gas laws. Oh wait, I hope this is CSEC and not keep. Anyway, for this month. I will figure it out. Wait, just now, yeah. Why so small? Where is it? Oh, the scene that already. All right, log in. Let's go. All right, ready? Caleb, I'm not seeing you there.
Oh shucks. Unlucky, sir.
All right, hurry. Log in quick. I said some gas laws, right? No looking back, right? Might need a calculator for 1 or 2 items. Somebody can log out there. All right, let's go. Wait, somebody can log out. Oh, you have log back in. Hamlet. Caleb, 1 minute again. I started. All right, Caleb, got you. Just waiting on Hamlet. All right, let's go quick. Seven questions only. Hey. Here we go. Someone get that wrong? Who put one? Nathan, how's you? I will see who get it wrong, huh? So everybody else get it wrong. Huh? You put one? How much you put? Three? Yeah. Unbelievable, they get that one wrong. 4 gas laws, you gotta include general gas law too. Amen, amen. Everybody get it. Upside down. Nathan, Savira, Dr. Raj. You get disconnected. You can log back in. Try quick. Oh. Next one, true or false again. Let's see. Take your time, huh? Take your time. It's one on volume, huh? Not volume. Right, so the answer is true. It's inversely proportional to volume, right? Not one on volume, right? I sure went on here. Noria take over. Ooh, Sabira close. Nathan there too. Upside down. What happened there? You get that one wrong. Who coming up there? Cleo coming up. Chloe, I mean, coming up. She jumped 4 places. Caleb, I'm senior. To show Anna senior.
I read
Stop looking back, yeah? Look back. People get this wrong way. Hey, I'm just do it, you know. Hey, look close. Look close. Two more. So you have true and false here, right? I'm adding some calculations here, right?
That's fold up foil and take it easy.
People get wrong again. There's the end here, you know. We're gonna separate all the sheep and goats here. Calculation coming. Oh no, it's not calculation. That's the one, sir. All right, 11 people get wrong. I don't see those 2 people there, right? We still have one here now. No change to the top. Ooh. Come on, I must have a calculation. Please tell me I put a calculation. Yes, calculation. No, it's not calculation, so spell it properly, yeah? Lowercase or capital? Lowercase. Can't believe I have a calculation there, boy. Oh yeah, for you, spell it quick. Wait, it had no lowercase. Anyway, Calvin is a capital. Okay. All right, let's see what happened. Third belong upside down, script third still. 2 is Severa and who won? Nuria, well done, Nuria.
So I
Third and
wasn't here
fourth.
on this, so I didn't have all the notes.
Tiana and Nathan. But he was here for everything. That's from today alone.
I wasn't here Monday.
No, but that Kahoot was today alone.
Wow.
Yeah. All right. Good job, all you. All right. Let's do one calculation from a past paper now, right? There's our next Kahoot, but we didn't do some of the things as yet. All right. Seeing them shorter classes, I can't do it all the time. Once you come Ashton, you can log out again. Or your phone die. Oh. All right. Let's see if we can squeeze in a past paper. All right. Let's see if we see it here, right? This is the first one. I don't remember the years earlier, but this is basically the setup for one of the laws, pressure law. You all recognize why is pressure law? Watch it here. What they keeping constant here? Watch it good. What are they keeping constant here? Volume, right? Because the container, the shape of the container now going to change. You're going to heat it up, temperature will change, and your pressure, you'll get a reading for pressure. So pressure and temperature going to change. Okay? All right, so that's pressure law they're trying to test it. This is a real simple thing. Try this, please. I don't remember what year it is, right? Try this. All right, convert to Kelvin. You gotta remember what to do. What to do? Add 273. Nice. Convert them all to Kelvin, and then is the pressure law supported by the data? Don't just put yes or no. That's 5 marks, huh? 5 marks, Nathan. So you have to get them 5 things to mark. Well, not really in this case, but yeah. Who's that? right, last one. Let's see what we got. So you're adding 273 to all. So that's 308, 336, 364. That's okay? Right. What do we recognize? Is the pressure loss? Is the pressure loss supported? So the first thing I will do, I want to get 5 marks. So I will tell them, well, the pressure law states that the pressure and temperature are directly related. So are they directly related? Let's see. As the pressure increase here from 308, sorry, as the temperature increase from 308 to 336 to 364, the pressure also increase. And you can say vice versa. As the pressure decrease, the temperature also decrease. So therefore, the data supports pressure law. Okay? We can say the data supports pressure law. That's okay? So the answer is yes. The data supports pressure law because as the temperature increased, the pressure also increased. Saying that? Savira, you sure? And we had one more to do. Any questions online there? Wait, they don't type out the whole thing. Okay? So in your explanation, the first thing you will say is what is pressure law? Tell them how they relate. Huh? She's going to come back. Pressure law, pressure increase, temperature increase, pressure decrease, temperature decrease. And because of that, we can say that they're directly related and therefore they support pressure law. That's it. I had a next one here for you. That's the wrong thing. Wrong thing. I had this one here for you. Somebody can just screenshot it and send it in the group, and I can try it for homework. Try it for homework, please. Anybody can just screenshot and send in the group, please. Screenshot and send in the group, please.